come on. Look, so this is a weird slot and a weird room. So I do actually have to congratulate all of you because nobody finds this room by accident. So hopefully you aren't expecting to see Heather Downing and her war stories. If you are, you're in completely the wrong room. Now's the time to go before I judge you slightly. Right, my name's Laura. It's lovely to meet you all, and there are still people coming in, so welcome to you too. A little bit about me. Now, some of you may have already met me so far this conference and be a little confused as to why on earth I'm on stage here. I need to talk to that a little bit. So my name's Laura. I've been doing application security for somewhere around 20 years, but it's kind of rude to say exact numbers at my age. And before that, I was a software engineer. And I've done everything from COBOL systems for the tax office here in sunny UK, through to radiation monitoring software for CERN, through to production PHP and Python, and every horrible mess in between. Now, as well as running a small company, and that's what you'll see me doing downstairs, this is my field. This is the field that I've spent most of my career in. I'm a published author. I speak at conferences. So I can give you my absolute hand-on-heart assurance this talk has nothing to sell you. There is not a single thing in this that you cannot do free of charge with your own time and energy and effort. So please don't conflate the two. I speak because I am a speaker and a researcher, and I do the stand because I run a business. Don't do both, it's a stupid idea. Right, I want to kind of put the room at rest a little bit before I get into the meat of this talk. Now, let me just see who we've got here. Please raise your hand, up and proud, if you are a developer. Wonderful, good. I'm not in the wrong room entirely. Raise your hand if you work in the security team. Oh, one or two of you very shy to admit that. Okay, good. It's all right, these are nice people, I'm sure of it. Raise your hand if you are somewhere in between and somebody has made AppSec your problem and you're not really sure where this all begins. Good, fabulous, okay. Right, so it should be comforting for you then that I've done a lot of surveys, I've asked a lot of questions in this space. And while there are a lot of people who will stand on a stage from places like Netflix and Facebook and all those companies and tell you how amazing they are at security, they represent probably only 2% of software teams on the planet. The rest of us are somewhere else. Some of us are exploring. Raise your hand if you're doing some stuff, but you know, there's work to be done. Raise your hand if you're like, I know we should do some stuff, but I don't know where to begin, and no, we're not really doing anything right now. Of course, only being recorded from the back, so they can't see your faces. It's okay to be at the very start. It's okay to be a chaotic mess. That is all fine. This talk is highly practical. I'm going to give you a whole bunch of stuff you can take back to your teams and do. And if you then want extra things, OWASP, which is one of the big non-profit organizations in AppSec, have a stand on the 5th floor, and you can go talk to them about some of the free tools and things they have. So wherever you are, start there. This talk came about because I've been doing this for a very, very long time, and I realized we had a bit of a funny view of how security works. Now, this is a view of what the solar system, or what people believe the solar system looked like a very long time ago, or still recently, depending on which parts of the internet they read. But we have Earth in the very, very middle, us at the center of the universe, and everything else sort of fitted around us. Now, we do the same thing in our software. We put the view of where security fits into our software in a very strange place. Now, this is an oversimplified software development lifecycle. You will have one that looks a bit like this, a little bit different. Some of you will deploy multiple times a day, and I'm awesome, I'm happy for you. And some of you don't, and I'm happy for you too. If it's still deploying at some point, this is success. Whatever yours looks like, I would bet that most of your security effort, if you do anything yet, is focused at the coding stage. In fact, we talk a lot and almost exclusively about secure coding. But software development isn't really all about coding. In fact, for those of us who've been around long enough, it only represents a fraction of what we do in software engineering. A lot of the work happens well before we write the code, when we design what we're doing, when we make those choices. And then a lot happens after that code is deployed. Please raise your hand if you have written software in your life that you wish wasn't still on the internet. Yep. I think I've got pieces of code that I know are still live that are old enough to have completed university by now. So I'm horrified for the internet because that's what we're looking at, right? We're not looking just at the code that we write today. We're looking at securing our software for its life. And that's a very different challenge. So we're going to move from this current, very code-centric approach. There's nothing wrong with it. You know, we do need to do things in the code phase. But we're going to branch out. We're going to put it through the entire life of the code and through our entire software development lifecycle. And it's not just the SDLC, it's causing this blind spot we have. I'm going to also look at a few other things. Who remembers the conference that started with this? Yeah, hi, old people. I remember it very clearly. Some famous guy at a conference. Developers, developers, developers. Everything centers around developers. Raise your hand if you have other people on your software team other than the people who write code. How many of you would feel bad if you didn't have those people because they actually have really useful jobs? Yeah, absolutely. Our software teams are not just software developers. They're an entire cast of characters. And so our current approach, largely, if you start reading enough books and papers, is that we write good code, that will solve all of the security problems, and hire experienced senior developers only because they don't make any mistakes and they know how to do security. Right, good. It's not entirely true, though, is it? There's nothing inherent about being older or senior that says that the ray of security has been cast upon you and now everything you write is perfect. In fact, depending on your background and what adventures you've had in your career will really dramatically shape how you approach security. If you work for a bank or a fintech right now, you've probably got quite a strong idea of where security fits in. If you work for a B2C company, an e-commerce site, for example, your exposure to security will be entirely different. If you write the software for a children's toy like a Furby or a VTech fake computer, security is probably not part of that world. But I believe that all software should be secure and that security is part of software quality. And so we can't just rely on these things. We're going to do some things that involve everyone. So whether you're a developer, UX, tester, you're an analyst, an architect, a product owner, everyone can do a little bit. I'll give you those practical steps. So what we're going to do in this talk, I'm going to go through the whole life cycle. And for each section, I'm going to give you some things you can think about and a little bit of homework. Now, don't be too offended by the homework. This was always going to be that kind of talk. Any talk that says practical steps means go do things afterwards. If you're worried about taking notes, please don't. There is a slide at the end that you can scan the little code, and you can download the slides. So they're all there for you. And if you have any questions, I appreciate in a security talk, it's not easy to put your hand up in front of a room of strangers and go, hey, my baby is ugly, and please let me share the details. Please do come and find me afterwards if you would like a one-to-one conversation, because I appreciate this isn't a safe space always to discuss these things. So let's get started. All right, designing software. I love design. I love architects. How many of you are architects? Any of you got the job title architect? Cool. Please do not be offended by the following. There are two types of architects I encounter. I've been doing this a very long time. There are architects who are formally trained. They have their TOGAF certificates, and they're very good with Visio, and they're very good at documentation. And then there's the other type of architect. And a lot of the other kind of architect have worked in many places in the organization. They know how everything strings together. It's much more practical, I've lived through this sort of architecture. And depending on your organization, depends on what type you will have. If you work for a large, older organization, it's more likely you'll have traditional architects versus the ones who've just come up through experience. Now, I cast no judgment at all as to which side you are on. But I do resent the fact that we think that you have to be an architect to think about architecture, because that's not the case at all. Architecture is how we structure, how we design things, how we bring them together. We've had lots of architecture-centric talks in this conference, and there will be more to come. We've got people like Sam Newman talking, who talks a lot about microservices and monoliths and all of those kind of things. Every single one of us who builds software has a role to play in architecture. Now, I want to talk to you a little bit about why it matters. So this is my artistic interpretation of a castle. I'm not an artist. So castle-style security is our old school way of thinking. So if you don't like castles, think of them like an armadillo. Hard plating on the outside, and the hope is that you don't penetrate the external defenses. You store the really great stuff in the middle, okay? I do this talk around the world. This is one of the few countries who has enough castles that this should make sense. You should have all been, shown castles at some point in your youth. If not, go watch some Game of Thrones. That'll do the job. But there's a big problem with this. Castles weren't just built with one wall, and that wall withstood all of their things. They were built with hundreds of defenses, and they all worked together as a security architecture pattern all of its own. Right the way to the direction that the staircases turn in towers, which favors the defending swordsperson, not the attacker, which I think is fascinating and also incredibly nerdy. And whoever came up with that back in the day was a genius. Our systems don't look like that, though. They look like these big spread out things, right? We can't just put a big board around the outside and hope it works. Raise your hand if you only write internal facing systems and so you're okay. Oh, there's going to be at least one of you in here somewhere. That's okay. That's like an armadillo, right? Hard plating on the outside, flip it over, tickle its tummy, and it giggles. Because the tummy's super sensitive. Now, during COVID, we learned lots of architecture lessons about security because a whole bunch of applications that were built to be internally facing were published online because we needed to get to them because we were working from home. So we had organizations who had incredibly tight security around production applications, exposing these internal systems suddenly in a new way. And so we don't have a border. When we're thinking about architecture, we're not thinking about one control. We're thinking about looking at all of the components of the thing we're building and finding all of the things we need to put in place. Let me walk you through it. I want you to imagine for a second that a big bear walks through that door. We're not talking Paddington, we're talking like grizzly bear. Cool, all right, it's a bit lost, I'll give you, and it's made it to the room 6 of this conference center, which is incredibly unusual for a bear. But it wants something in here. Let's politely say it's honey and not your internal organs. Cool. This is a typical threat scenario. You have something that wants to do you harm. You have something that they're motivated to go after. Now, in your organizations, it won't be a bear and honey. It will be some group or individual, and it will be something in your systems that's worthwhile for them. So it could be data, it could be money, whatever it is. But let's go back to our bear. What do we do if a bear comes in? Well, I could put bear traps all over the floor. I mean, it'd be pretty hard to travel with them, and it's going to take some time, but we could do that, right? We'll stop the bear. It's what we call a preventative control. Prevent the bad thing from happening. Not very practical, though, and I feel if any of you chose to run, I think we're going to have a little bit of damage on the way out. So instead, I might install cameras so that I can make sure I know where the bear is at any point so that I can run the opposite direction. That's what we call a detective control. And my choice to run and the idea that I have planned my escape route is what we call a responsive control. So in architecture, what we're looking to do is take any environment, identify who or what could do us harm, and plan those preventative, detective, and responsive controls. Now, this comes with an idea that marketing companies love using, and they often use it really badly. It's the idea that we don't trust anything or anyone, zero trust. That a risk can come from any aspect of your environment. And rather than us sitting here and debating, will a bear come in this room or not, we just take precautions to make sure that for any given scenario, we've got some form of controls in place. Now, we're not likely to put preventative bear controls in because it's highly unlikely. But this building is full of cameras. So they can detect strange things, of which a bear is one of them. Zero trust in our architecture is incredibly important, especially if you work in that internal application space, where we tend to trust a lot more deeply than we should otherwise. Now, raise your hand if you've ever made a mistake in your day job. How have you made a mistake so far this week? Great, good work. Internal threat and internal systems threat often doesn't come from malicious actors at all. It comes from us having a bad day or making a mistake. So zero trust means that we take our architecture and we all put our architect hat on, whether you've got the job title or not, and we choose the right preventative, detective, and responsive controls to go through the entire piece. Now, you don't have to do all of them. This isn't like Pokemon. You don't collect them all and then you win. Your job as engineers is to look at the architecture and look at each piece and go, right, what are the best controls I can put here? And the idea is, over the entire architecture, that those controls work together, so that if one control fails, another control somewhere else is going to complement it and compensate for that. I'm not going to go through what all of these words mean. They're really well documented online. You can look at the slides afterwards. And if you're not familiar with them, the first place you want to start is with, if you have them, an internal security team, because you might find you already have some of this. And just figuring out where it is right now, and if you have any blind spots in your architecture, can be really, really powerful. Now, if you don't like doing the work yourself, I'm a proponent of very selective times of being very efficient, or as my mum likes to call it, very lazy. There are entire libraries out there of design patterns for security architecture. So this one is for a payment system. It's part of one of the OWASP projects. I'm going to link on the next slide. So you can actually go and say, right, I'm building a payment system. I'm building this, that, or the other. What kind of controls should I put into this? So don't feel the need to build your own. If you are a small team, you don't have this already, go look at the design patterns and see what you can adapt for your space. So some projects you want to look at: OWASP Threat Dragon, the Threat Modeling Cookbook, and Threat Modeling Manifesto, which are all three great free resources that can give you these patterns, and you can start thinking about where those controls fit. And we're doing this right at the start, right in design. So your homework for this section, I want you to map out all of your systems. Now, that actually might be a lot of homework for some of you. So get your whiteboard. It doesn't have to be pretty. Do not go and buy a license for Visio. I want you to map your systems, your products, and all the connections between them. Let's call it our architecture diagram. And then I want you to start annotating it and going, right, where have we got any security right now? And then start looking for, okay, what gaps do I have? Weirdly enough, we spend a lot of time putting tools into our deployment pipelines and not a lot of time looking at what our system looks like and how it all strings together. So start there. You can also do a simple threat model. Now, a threat model, as I've said with our bear, is someone or something is going to do you harm for a reason, and you come up with a list of how that works. And the links I've just previously mentioned will guide you through that process. So let's talk about code for a second. Now, given the heritage of this conference, there's probably a lot of .NET developers in the room. Raise your hand if you're .NET. Raise your hand if you're something else. Cool. All right. Don't worry, .NET people. I'm going to take away your sense of security in just a second. Cool. So let's talk about code. I'm not going to talk about the syntax you write. There's lots out there on that. I want to talk about the software you build software out of. Now, this is a picture of the Node ecosystem. And the only reason I've chosen the Node ecosystem is somebody was nice enough to put together this wonderful tool that visualizes the transitive risk or the relationships between all the packages. Now, that's cool, but it's got an important lesson for us in security. When we are connected to other things, we inherit risk from them. So we call this third-party risk or transitive dependency risk. So if you were able to either compromise or remove a node, all of the nodes that are connected to it, whether directly or indirectly, are impacted. Now imagine for a second that we do this for real in this room. Imagine that this side of the room, you're Camp A, this side of the room, you're Camp B. And the only person who's ever been in both camps is the lovely lady in the purple jersey at the front, because she's a crew member. So if we're looking at the network of connection between you, she is a vital piece. And if we're able to give her £1 million and tell her to go and have a wonderful time in Hawaii, suddenly the connections between you are gone, and we start seeing an integrity problem. Now, at least one of you's gone, yeah, but this is Node and Node is feral. Raise your hand if you were like, yeah, but Node. Yeah, it's all right, I don't judge. So there's an interesting bias we have in software that Node and these newer things have more transitive risk than things like .NET, C#, Java. The average size of a dependency in Node, if you were to install a library, is 7 lines of code. But they do bring in a lot of packages. The average length of a dependency in C#, .NET, or Java is significantly more than 7 lines of code. And so while you don't bring in a lot of packages, you bring in a lot of code. Now, if we have a look at that slide there, this is all of the major package managers out there. It's from a lovely free open source tool called libraries.io. And they just tell you when there are new packages available for you to look at. Now, admittedly, you've probably got tools in your lifecycle that do that for you, but if you don't, it's another freebie you can go and have a look at. What I find interesting is NPM, so Node, got 2.37 million packages. That, for me, is an astounding amount. But then you look at your world, so if you're looking at, say, NuGet, or we're looking at, look at Clojure there, Maven, all of these bigger ones, yes, they have much less dependencies, so 474,000 in the case of Maven, but they're huge. So we often say, well, don't use languages like Node because you inherit all these packages, use something like Java or .NET. The problem is, if you inherit one of these packages, what are you getting with it? Raise your hand if you do a code review of every package that you bring into your lifecycle. Oh, good for you. Do you do it by hand? Oh, amazing. Good. You're having fun times. Now, I want to show you an example. It'll hopefully tweak some little bits of bias in the audience. So before this talk, I pulled a picture of, I'm a Python developer a lot of the time at the moment. So I was like, right, I'm going to go after a cryptocurrency exchange package because I totally need one of those right now. So this is just the picture of the front page on GitHub. This is typically where you would start when you're pulling a new dependency. Cool, I'm going to do this thing. Maybe you've just pulled it from NuGet or Maven and you're not going to look at detail, but most of us will at least go and look at the package and see what's in it. Which bits of this are important to you? Which bits are you paying attention to when you code review this, when you decide if it's secure to use?
The number of stars.
Always, every time. I could have planted someone in the audience, but I never would. Number of stars. See, I find number of stars hilarious because to some people like you, it's a badge of quality. I star things that I think are funny or that I want to come back to later with and play with, not in necessarily a good way. Or things that I need to show my friend because it's just dumb. The things that we look for in our software is an interesting bunch of criteria. It's not always a sensible thing. Now, theoretically, if we're going to inherit the risk of this code, we should treat it the same way as the code we write, which means it should go through a full code review process. And for some of you, you'll be running some tools that maybe do some of this for you. But for many of us, we look at a superficial level at the package, say, does it do the job? And hope the rest sort of figures itself out. So to make it easier for you, I'm going to give you a little checklist as part of these slides. So at a minimum, when you're choosing a new technology, I want you to think about these things. And I want you to be brave and say, if it does not meet these things, I will not use that library, which is the hardest part of this entirely. So check the license is suitable, especially now. Especially when we're in an age where people are using all sorts of data to train all sorts of things, check the license isn't doing something strange. Check that it's regularly released and governed in some way. Make sure that it has active issues that are being resolved. All the kind of things you would hope. All I'm doing here is turning this into something concrete that you can work your way through. I'm not saying don't use third-party libraries, that's naive. But what I am saying is when you do it, have a consistent process to choose them. The other thing you can do is you can put a little check in that will check these for you. So OWASP, the Open Web Application Security Project, or World Application Security Project, depending on the generation you're from, they have free tools available that will allow you to check dependencies to see if there are known vulnerabilities in them. So that's a good place to start. If you're using GitHub, turn on Dependabot. Let it tell you if there is a CVE in the code that you're using. All of these things are free. They're all around you already. Okay, so your action, your homework, use that checklist every time you update a library or framework. Raise your hand if you have libraries and frameworks you know full well you can never update. Yeah, these are the bits we never talk about in security talks, right? We say, oh, update it all, it'll be fun and easy. It's not fun and easy. There are many reasons we don't update things. We don't update them because they're going to break everything, and we can't use the latest version. We don't update it because when we say one thing has changed, actually 4,000 things have changed fundamentally. Or there's no update available because they stopped making it. Now, in those cases, I want you to have a plan. Much like when we talked about our preventative, detective, and responsive controls, you need to decide if I can't change it, if I can't fix it, then I need to wrap it up in something. I need to monitor it. I need to make sure that there are other controls in place. So please think about that explicitly. It's very cheap. It's a throwaway comment for me to say patch all your stuff. But the engineer in me knows you can't. And therefore, we have to be a bit more creative. All right, testing. Testing, for me, is a superpower. I think they are some of the most undervalued members of our team, and we don't give them enough time and resource to do what they can do best. Now, let me explain what I mean by that. Humans are great testers, naturally. Ever since you were a kid, you have been a good tester. And by that, I mean, if somebody passed you something as a kid that had buttons on it, some of you, one or two of you, would have been like, I'm not going to touch this because I'm well behaved. Raise your hand if you were pushing those buttons. Raise your hand if you were then going to stick a jam sandwich in just to see what happened. Kids are natural testers. We don't believe in boundaries. We don't really understand physics. The law is this abstract thing we don't really think about. It's only when we hit school, and then increasingly into adulthood, that we start reining in our behaviors and stop testing things in the way that we naturally can. Your testers are the few people in your team who can still sit back and do that. So you need to give them space to roam. We, hopefully less and less these days, we often use things like test coverage as our quality metric for testing. It's a terrible quality metric, because just because something has a test, it doesn't mean it's a good test. But getting security into your testing can be really, really beneficial. Let me show you an example. Now, this is a security test written in the same language that we build all of our other tests in. So it's a Cucumber-style language. This scenario, we've got username enumeration. So for those who aren't familiar, username enumeration is a vulnerability where you can go to a website, somewhere like, say, the forgotten password page. You can put things in the box like email addresses, and it will tell you whether that's a valid email address or not in the system, so that you can create a list or enumerate all of the potential valid IDs in a system. Now, yes, it's a vulnerability. Yes, there are common solutions out there, but it's actually quite a complex one to fix because it always appears in three places in an application. Your forgotten password, your login page, and your account creation. And the account creation is incredibly difficult to solve because you're getting people to choose a username, and therefore they need to know if their username is available. So it feels to me, if it's a really common vulnerability, we should have a test for it. And this describes the test. So given that the user navigates to the authentication page, cool. When the user enters a username from valid username, so we know it's a valid username in the system, and the user enters a password from invalid password, so this is a bad authentication attempt, and the user submits the login form. So we're going step by step on what the testing flow is here. Then the resulting message should not identify the username is valid within the system. Cool. That sounds really easy, doesn't it? It's not. The reason these need to be tests is that last line is really deceptive. So it could mean that the error message has nothing specific in it, or it could mean that the page load time is identical whether you serve a good authentication request or a bad one. It can get down to the length in bits of the page. And an attacker is just an engineer with a different motivation set to you. They're not doing this by hand. If you had to go and look at a page response every time and see, is it changing, you're going to write a script for it. And that's what they do. So we can write these tests so we can start thinking them through logically with that engineering side of our brain, and we can start writing the little scripts that can tell us, do we have this problem? Does it solve the problem? No. But what it does do is give us an indication of where to be looking, what we can control, what we can't control. So you can write tests like this for any security thing in your system, and now we live in the golden age of AI, or large language models anyway. I have feelings, but they're not for this talk. You can actually get your tests written like this, auto-generated. Like, there's nothing potentially sensitive in this. This is a standard design pattern that is in almost every application. It doesn't need to know anything about your business, but it can do that for you. So we can actually speed up this process and get security testing coverage that is specific to our organizations. We can also link the testing to our threat model. So if, for example, you run an e-commerce platform and denial of service is a massive problem for you, say you're Ticketmaster and Taylor Swift is coming to London, I would guess, but you'd have to correct me if I'm wrong here, that making sure that thing doesn't fall over on ticket launch day is pretty high on your list, which isn't necessarily just security, it's also resilience and integrity. But if your threat model is Taylor Swift is going to come, then you need to test for Taylor Swift coming. If your threat model is actually the interest rates went down today and 50,000 people are going to apply for a change in their interest rates in the next 24 hours, that's your threat model. If you happen to sell something that has a lot of value, or you're an online community that's being used for nefarious means, those are the tests you need to write. Now, there's two types of testing I want you to consider. You may be doing some of it already. There is vulnerability scanning, and there's automated testing. Now, I'm going to use COVID as a bit of a metaphor for this, just because it's fairly recent and we all experience it. So vulnerability scanning is the equivalent of me taking your temperature. If I take your temperature and your temperature is elevated, chances are you're sick. I can't tell you how you're sick, but that's not right, we should go and investigate. And that's what a vulnerability scan is. It looks for the common signs that things are going wrong, but it can't tell you in detail where specifically it is or what it is. It just knows bad things, go look there. Automated testing is a specific medical test. So this is taking your COVID test or going and getting a flu test. It's looking for the specific symptoms of a vulnerability so you can name and fix it. You want to do vulnerability scanning frequently. This is your low-hanging fruit, but trust it to only a small degree because it's going to be noisy. Your automated testing is the high-value stuff. So make sure you're doing a bit of both. Most of us focus on vulnerability scanning because you can put a box into your life cycle and go, and it does results, and yay, we've done it. But really, it's the other side we need to do. Now, in terms of common issues we have with this, and there are many, when you start putting extra testing into your life cycle, it starts to slow things down. Raise your hand if you do some form of continuous integration or continuous deployment. Cool. So the most common pushback security ever gets from this is that you put something in, you put extra testing in, you put a vulnerability scanner in, and your build time goes from 4 minutes to 4 hours. That's because security teams and security tools are not really built by the types of engineers we are. They don't live in the same world. They're still good tools, but they're not designed to run in a couple of minutes. Often they're doing a lot of checks, and you need to tune them quite aggressively to make sure they're just checking the right things. Now, in these cases where blowing your build up to 4 hours is not perhaps the best outcome, you have to figure out, well, how am I going to do this instead? So you could run it manually. So I'm going to run this once a month by hand. You could have a parallel pipeline, which you do see some people spin out a second pipeline just to run these things. Or you can have it integrated directly. My key advice for you on this one is nothing about running the tools. Running the tools is the easy bit. Fixing the issues is hard. So do not run your security test tools on every single build if you know you're not going to be able to resolve them by the next build. So if you know you're going to have to take 2 weeks to get it into prioritization to get it done, run your tools every 2 weeks. Because having this massive growing mountain of security problems you can't fix does more harm than good. So it's not a failure to slow it down. It's not a failure to go manual. The failure is to not do it at all. So what's your action? I want you to stop considering test coverage entirely. It's rubbish. And I want you to explore more. So I want you to think about those threats from earlier in our talk, what could go wrong, and I want you to test those things. And I don't want you to theoretically test them. I don't want you to sit in a room and go, on paper, we'd be fine. I want you to sit down and simulate it. Now, I don't mean pulling out the infrastructure plugs somewhere. That's a terrible idea. Unless you're Netflix, don't do that. But it could mean sitting down with a group of people and saying, okay, we're going to simulate the following. And let me give you a scenario. Imagine you work for an e-commerce platform or a bank, and you're logging, or something detects that there's been a minute change to a fixed value that's used in financial transactions. Let's say it's a GST rate or VAT rate over here, so a tax rate, and that has changed by just a small percentage. And you discover that you don't know when it happened. Now, that is a weird situation to try and investigate. But you sit down with your people and you start asking the questions. So how do we know it happened? How do we know when it started? Now, in this scenario, when I've run it with other organizations, I had one that said, cool, we only keep our logs 2 weeks. I can't tell you when it started. And I've had others say, I'm certain we keep our logs forever. And they had no logs at all. I want you to make the assumption we do a thing, but then I want you to validate it. I want your testing to be more than a script. I want it to be scenarios. I want it to be really testing what your systems are doing. And then comes the fun part. Now think about our theoretical situation again. We've had a change in an interest rate in an app. Let's say it happened 6 months ago. Now, how do you recover from a data integrity problem that's been used in every calculation in your application for 6 months? That's brutal. If you are not a database person, go find one and they'll cry at you when given that scenario. Because testing isn't just about finding the bug, it's what do we do with it now? You can't just go back to your backup 6 months in the past and go, yeah, we'll just reset. And if you're a bank, or if you're a fintech of any kind, or maybe you're a health system, and we're not talking interest rates, we're talking about customer patient data, then the aggregate impact of that is huge. So come up with the things that terrify you. I want you to have the list in your head of the worst possible things that could happen specifically to your application, and start there. Let's talk about deployment. I love robots. My first mentor, I used to work for various government organizations in the UK, and I had some really amazing mentors. But one of them, he was also my boss. And on my first day, he gave me this laundry list of jobs, and they were all terrible. I was like, what? Like, have I offended you in some way? He said, no, this is all of the boring stuff I don't want to do. I'm like, cool, great. He's like, you're going to learn automation. And once you've automated all of these boring jobs, come to me and I'll give you exciting stuff to do. And so off I went. One of the best things you can do for security is automate it. You are literally engineers. This is what you do. So if somebody gives you a boring security job you don't want to do, script it. Like, don't sit on your secret superpowers and hope it's just going to resolve itself. Do not start doing this manually. I do not want to see spreadsheets. What I want to see is robots, because robots are the way we can do this consistently for everything we do. So the best security is the stuff you do not have to remember, because it's been done for you. So find the requirements, find the things you need to do, find the solutions, and then script it. And then I want visibility on that script. I want to know how often is it running? What's it found? Now, I don't want it to spam everyone, because alert fatigue is very much a big problem. But I do want to know it's still alive, and I do want to know when it finds something bad. That's what I want. And my perfect world, I run a teeny tiny company, there's only 6 of us. There are more robots in the company, I would say 6-fold to the number of people in my company. They have their own channels in Slack, so the bot channels, so you can go and hang out and see what the bots are up to today. But this is the future. It's not going to give you the space and time you need if you keep doing it by hand. So here's some things you can do straight away if you happen to be a GitHub user, for example. So you could create GitHub Actions. They're a great way to do security automation. Now, there's a bias in this. It's only going to work when you're deploying or building the code. So once it goes out of active development, you're going to have a bit of a black hole happen here. But look at turning on Dependabot. Look at things like TruffleHog. So TruffleHog is a free open source tool. Its job is to find secrets in your code. So it can find AWS keys, passwords, all of those kind of things. And you can do it just from the clickable UI menu in GitHub and get it to run. Now, if you've never run tools like this, before you do them automated, go run them a couple of times, see how they feel. Sometimes they're a bit noisy. You can get linters that help you with security things. So pop some of those in. If you're in Ruby land, there's loads of wonderful things. Python's too. SAST and DASA, that's analysis tools, either static or dynamic. So is it scanning your static code or is it running against your dynamically deployed application? That's the key difference there. OWASP Zap is a vulnerability scanner, and it's free of charge, so it can find that low-hanging fruit for you. Put it all in. Do not put it into your production pipeline without permission, and do not do it without checking how long it takes to run, but create your robot army. You'll thank me later. So I want you, whatever version control system you are in, you can do this kind of thing. I want you to go and set up at least one robot. And I want that robot to tell you it's alive every so often, and I want it to tell you when something's wrong. That's all it needs to do. And imagine what would happen if we all set up one little robot each that solved a common security problem and then just shared them. This actually wouldn't be that hard a problem if we all kind of shared the engineering outcomes, because they're all the same almost every time. Let's talk a little bit about support for the last few minutes. So this is what happens once the code has reached its final destination. It's out in the world somewhere. People are using it, hopefully, happy days. Now, the reason we talk about this is because things go wrong. Some of the scariest things that a dev team can encounter are not the things that happen before production deployment, it's the stuff that happens afterwards. How many of you have ever received an email going, "Hi, dear sirs and madams, I have found a vulnerability in your software. Please, do you like Bitcoin? I like Bitcoin too." No? None of you yet? Oh, a few of you? Or you've had a customer ring up and say, "Hey, look, this might just be me, but there's transactions on my account and they weren't me and something's happened." Cool. What we're talking about here is incident response. Now, in a lot of organizations, the software team is shielded from incident response. We put it in the security team somewhere else. I would aggressively challenge that, because the people best equipped to help deal with a breach of software are the people who built the software. You, as engineers, should always know how happy and healthy your apps are. You should be monitoring them. You should be looking for these issues. And you should be connected to teams like customer success and support, who are the ones who are taking these calls. And then you need to have a plan. Now, airline safety cars are my favorite incident response plans on the planet. They have a very set of rules from the FAA that they have to have on these cards. But they have to communicate it in the space of one sheet of A4 paper, essentially. And they have to do it in a way that, regardless of what language you read or write in, that it makes sense to you. And that is a really good way of thinking about incident response. Incident response is not about building a tome of a PDF. It is about finding the simplest way to communicate what to do when things go wrong. And then you test it. You test that these instructions work. Now, incident response is an interesting process, and it's the same whether you're in AppSec or you're in other part of the world. And you probably already have incident handling, just not for security. You do it for outages or downtime or degradation of performance. And the idea is we identify there's an issue, bad thing has happened. We verify it. Is it really a bad thing or is it a false positive? What's the scope of this? How many people are affected? We contain it, so we stop it from spreading, and then we remediate it, we fix it. And then there's this feedback loop where we loop and loop and loop until we're sure that we fixed it. The bit that's not mentioned on here is the after-incident review, which you might call a post-mortem, and that's a key part too. But the process is the same wherever you are in the world. The key things we can do as engineers is understand the scenarios that can happen and how we would know and what we're going to do. Let's talk about them a little bit more. So, common scenarios that I highly recommend if you're an AppSec professional or an engineer that has inherited some AppSec responsibility, these are the ones that are most common. So having a playbook for each of these is a really good starting point. And it doesn't need to be complex. It can just be a to-do list, little tiny, 5 steps. This is what we're going to do. Account compromise. So password breach, huge impact on our applications. It often feels like it's not our fault. If a user chooses a bad password, that's on them. But we still have to respond. Unauthorized query or data export. This can be a really interesting one depending on how mature your logging is, as how you would even know. For me, I love the slow query logs on most database engines because when you get an unauthorized query, they've not been optimized in any way. And so you end up seeing these spikes in performance. Data exposure. I can see other people's stuff. That's pretty bad. This is one you don't want to find out about from the public or from the newspapers. Permissions escalation, suspicious changes to deploys or build. Raise your hand if you have any logging and monitoring over your builds and deployments to the point where you would know when they're happening. So if a build kicks off at 2 a.m., do any of you investigate why? Maybe you should think about it. Like, fun fact, if you query the GitHub API, if you're in GitHub land, you can get the deployment frequency and the commit frequency for every person. And this will sound super creepy, so apologies. You can create like a little profile almost of each person and go, all right, this person almost always commits between these times and kicks off a build between these times. And then you can use that as your baseline in your monitoring. So if you know that, Laura only ever commits before 2:30 in the afternoon and never does anything at night, if my account starts committing and doing stuff at 2 a.m., either my account is compromised or I am having a very bad time. And either of those are worth investigating. So use your monitoring to look at these things and have a plan. Like, the plan should be, get Laura on the phone. What's going on, Laura? Why are you building at 2 a.m.? Oh, I'm not. What's going on? Different response plan activates. Or, actually, it's all on fire because there was a build and I made a mistake. We need a plan for that too. So I want you to have playbooks for these things. And the kinds of things you want to cover in these playbooks are these. So how can we verify it? How do I know that this has happened? How are you going to contain it? What logs do you have and how do you find them? Who do you need to contact, internally and externally? What's the sensitivity of the data that's impacted? Now, that does mean going through your systems and really looking at the data sensitivity. Where are the backups? When was the last time you tested them? And how do you trigger a restore? Where do you keep a record of the incident? Do you just have a Slack channel you discuss it in? Do you need a document? Where do you keep this stuff? And then what additional support you can need. Now, the best thing is the next step. Now, I'm a D&D nerd. I run D&D games for 15-year-old girls, which are the epitome of chaos. But this is where you get to have some fun. You take your newly created playbook and you go and have a play. You go and have a look at it. Now, I've had some people literally bring dice along, but go through your playbook. Role play it happening. Have somebody that's there to be a chaos person. And if you're not the group of people, if you're all very mild-mannered and quiet, find someone from out your team that can be obnoxious. Find the person who can sit there and go, but what if? But what if? They'll be annoying, I promise you, but that's the most valuable thing you can do in a role-playing situation for your incident response, because they're going to challenge you to go beyond just what's written on the page. The other thing that I don't mention in much depth that's really important is know where your identification points are. I've mentioned it on this. How do you verify the issue and how do you identify it? Now, depending on how big your organization is, you may never find out about your security incidents unless certain circumstances are hit. So if you're in a big organization and your call center handles forgotten passwords and weird account behavior and they never escalate it to you, you'll never know that there are recurring themes coming through. So when you're doing the identification part, make those connections so that you can really identify what's going on. I'm not saying for a second you need to buy security monitoring tools. You might get value from them, but your engineers, you already have a lot of data. You have a lot of logs. Use what you have. It's going to be phenomenally powerful to you. So what I want you to do at the end of this is to create an incident response plan. Doesn't need to be fancy, doesn't need to be particularly formal, just make something that says, hey, this is how we spot bad things. This is what we're going to do. Here's how we verify it. Here's how we contain it. Here's how we remediate. And do this as regular practice. I would suggest every couple of months, pulling people together and doing a different scenario. And it can be a great way to learn about how your team think and also make improvements to your system that aren't just security related. So that is our entire software development lifecycle. There's a lot of it. I don't want you to take away from this that security is overwhelming. But the key is that security isn't really about code at all. If we were in ye olden days, let's go back even further than that, we were cave people. And this cave over here had something that was incredibly valuable, and this cave over here didn't. What would this cave do? Would they politely negotiate? Probably not. You're probably going to attack this lot with weaponry, which in cave times, we're talking big sticks and heavy rocks. Wonderful. Security isn't a new problem at all. It's the oldest one that humans have. We're not very good at not having things. So security isn't overwhelming, it's built into you. Take little steps through everything you do so that by the time you get to write code, you've made all of these tests, you've made all these decisions, and will spot them quicker. And then don't forget that security lasts for the life of your code. So just because it's not building anymore doesn't mean that you're not responsible for it. So make your life easier by planning for it. So that has been my talk today. There was lots in there, and there's lots more up online. You can grab a copy of the slides at that little QR code there. You can come and talk to me on the booth if you want to chat through your information security or application security woes. I'm a good listener, and sometimes there's chocolate. If you have any questions,